this video, we are going to discuss the vertical and horizontal shifts of our quadratic functions and our parabolas. When you're watching this video, you should have already completed that Desmos practice, so you got a chance to explore these different transformations, and this lesson should review that and go through a couple more example problems. So the first thing that we have here is I have this red graph of y equals x squared. I want you guys to remember that y equals x squared is what we call our parent function. Right, so that's what we call our parent function. And that is what all of our transformations will be compared to. So as we go through these transformations, I'm going to keep this red graph here so that we can compare our different new parabolas. So the first transformation that you learned about was that k value that we add to the end of our expression. So I'm going to graph that in blue. And if we look, right now, we see a blue graph, but they look exactly the same. There is only one thing shown, and that's because k is 0. When k is 0, that's just y equals x squared. But watch what happens as I increase k. We notice that our graph is moving up here. Now it does look smaller, and we'll investigate that in a second. Now what happens as I bring k back down? Okay, as it gets closer to 0, it goes back to the original graph. And then as I bring it all the way down, you see now it's going below our parabola. I'm also going to add in our vertex point. So you notice that our vertex is going our vertex is changing, and the y value of the vertex is actually the same as the k value of our quadratic. Now we also notice that when we do this, it looks like it might be smaller. As I zoom out, you notice that the parabolas are actually the same size. All we have done is taken that small parabola, or taken the blue parabola and shifted it upwards. So those are what we call a vertical shift of our quadratic because we're moving it up or down. So let's look at what happens with that h value inside of the parentheses. You notice that when h is 0, the graphs are the same again. So when our shifts are 0, there is no change from the parent function. But now as I make h a positive number, you see that we move to the right. And here you can see that those two graphs are exactly the same, except one has been slided to the right. As I go back to 0, it gets closer, and then as I go negative, it goes to the left. And that gives us our horizontal shifts. We also look at our vertex again, and the vertex of these match up with the h value from our equation. So if we were to graph another function, so y equals x minus 4 squared. So you notice that in that case, the minus 4 has shifted our vertex to be at positive 4. So our horizontal shifts do not follow our normal idea of positive to the right, negative to the left. In this case, when the number appears negative, our vertex has moved to the right. That's why you notice here the minus sign is actually part of the formula. So we look at this value, and if it's a plus sign, then we take the opposite. But if it's a minus sign, we're actually just looking at the h. So now that we've looked at some different properties, we can look at our format for a quadratic equation. You notice that I have not talked at all about that letter A. We will talk about that next week, but right now we're just going to focus on H and we're going to focus on K. So the vertex of your parabola is always going to be H comma K. Remember, because H is how the x's are changing, K is how the y's are changing. So if we look, we can figure out the vertices of our four quadratics over here. So if I notice, I'll know that this is A, this is H, and this is K. Remember, H, the negative sign is actually part of our formula. So in this case, H is a positive 4 and K is positive 5. So our vertex is 4, 5. Now if we look at our next problem, I do not see any parentheses. If I do not see any parentheses there, then my H is 0, because x minus 0 is just x. And then K is negative 4, so our vertex is 0, negative 4. And we could confirm that by graphing it on our parabola. So we have y equals 2x squared minus 4. And if we go to our graph, we can see that we have, I'm going to turn that one on and it's green. You notice that our vertex has moved down to 0, negative 4 from that original 0, 0. Now we haven't talked about what that 2 in front is going to do, but because it's not being added or subtracted, it will not affect our vertex. So we notice that our vertex is just being changed by those numbers that are being added or subtracted. So let's look at another one. So in this case, there is no A value anymore, but we do have an H and we do have a K. Remember, H, we're going to be taking the opposite sign. So in this case, H is negative 3 and K is negative 1. So our vertex is negative 3, negative 1. And if we go back up, we could graph this as well. So x plus 3, delete all of that. We have x plus 3 squared minus 1. And if you look, there's our vertex at negative 3, negative 1. So a great tool you have is you can graph these functions and look at where your vertex is, because we've already practiced identifying the vertex. So that's another way to check. So in this one, I see my part inside parentheses is still my H, but there's nothing being added or subtracted on the end. So now H is going to be negative 1 because it's the opposite sign, but K is going to be 0. If K is 0, then our vertex is negative 1, 0. So a couple of key facts. You can check the vertex on your calculator, and our H value follows the opposite sign. So if you see a plus, then it becomes a minus. If you see a minus, then it becomes a positive. And that is how we do vertical and horizontal shifts of our parabolas.